Greetings for the day. Welcome to another session of soft computing. My name is Mohammed Ali. In today's session, we are going to learn about the unsupervised learning. What is unsupervised learning and what are the different mechanisms and things involved with reference to unsupervised learning. But before getting into this today's topic, let me revise that what we have studied in the previous session. We studied about the supervised learning, the types of supervising learning, the training models, and how the training models are being trained to get the desired output. In today's session, now we are going to learn about the unsupervised learning networks. Now, what it says, as the name suggests, this type of learning is done without the supervision. It means this learning is this learning process is independent. The learning process here in unsupervised learning is very much independent of the things. Now, in supervised learning, there was a mechanism in which the things were being learned in an environment wherein we were giving some of the outputs and we were giving some of the things to match with it, and we wanted some of the desired output in a required condition, whereas in unsupervised learning the process is independent. Now the second point says, during the training of artificial neural network under the unsupervised learning, the input vector of similar types are combined to form clusters. Now, when the new point input pattern is applied, then the neural network gives an output response indicating the class to which input pattern belongs, to which this input pattern belongs. Now, the third point says, in this, there would be no feedback from the environment as to what should be the desired output and whether it is correct or incorrect. What are the thing or what are the output that is been getting is the final one without any of the feedback. It means it is a continuous learning process in which correct, incorrect, everything is being taken into consideration, whereas in desired one we wanted the required output and according to that we have changed the way. Now hence in this type of learning the network itself must discover the pattern, features from the input data and the relation for the input data over the output. In the sense, and as the name suggests, it is an unsupervised type of a learning in which the output might be correct, the output might not be correct. Whereas in supervised learning, we had a continuous type of an output in which we were monitoring the outputs and we were redirecting the weights accordingly so that we can get the desired output. Now the second point it says, second one it says Kohonen self-organizing features map. Now what this is, Kohonen self-organizing feature map or SOM refers to a neural network which is trained using competitive learning. It is been trained using the competitive learning. Basic competitive learning implies the competition process that takes place before the cycle of the learning. Now what this is, the competition process suggests that some criteria select a winning processing or it selects the winning processing elements. After the winning processing element is selected, its weights vector is adjusted according to the use learning loss. It has been said by Nelson in 1990, like with the reference to a definition type of a thing. Now, what is this Kohonen self-organizing features map? It is a continuation process. Like what is the thing that we have been? We are continuing in this. A self-organizing map or SOM varies from typical artificial neural network both in its architecture and algorithmic properties or algorithm properties. Its structure consists of a single layer linear 2D grid of neuron rather than a series of layers. It follows a two-dimensional type of or two-dimensional grid of neurons. Now second point what it says is all the nodes on this lattice are associated directly to the input vector but not to each other. It means the nodes don't know the value of their neighbors and only updates the weight of their associations or as a function of the given input. Now the grid itself is a map that coordinates itself at each iteration as a function of the input data. It means, see, in the previous supervised learning, we know the weight, like what are the weights of the corresponding neighbors, we knew that weights of them, but in this unsupervised learning, we don't know the weights. So we are providing just the weights so that the proper coordinates or proper things can be done to get a proper output with reference to the desired learning process. Now, as such, after clustering, each node has its own coordinates I and j, which enables one to calculate Euclidean distance between two nodes by means of Pythagoras theorem. Now, what is algorithm for training? There are 9 steps involved in this algorithm of training, in which the first step is initialize the weights, the learning rate, and the neighborhood topological scheme. The second step says continue steps 3 to 9 when the stopping condition is not true. Now the third step says continue step 4 to 6 for every input vector x. Now calculate the square of Euclidean distance for j equal to 1 to m. Now what is the thing? The thing is d of j summation of I equal to 1 and summation of j equal to 1 of m xi minus wij and so on and so forth. This is the formula, or this is the method by which we will be calculating the distance for j from 1 to n. Now the step 5 is obtain the winning unit j where djj is minimum. The sixth step is calculate the new weights of the winning unit by the following relation. The following relation that it has been shown, w of I of j of new equal to wij of old plus learning of x of I minus wij of old of wij new equal to so on and so forth. This is the way by which we will be calculating the weights of the winning unit. Now the seventh step is update the learning rate by the following relation. Now the eighth step is reduce the radius of topological scheme. Ninth step is check for the stopping condition for the network. This is an algorithm for Kohonen self-organizing features map. Now further it says what are the learning vector quantization. What are the learning vector quantization? So what is it? Learning vector quantization or LVQ different from vector quantization WQ and Kohonen self-organizing maps KSOM basically is a competitive network which uses supervised learning. We may define it as a process of classifying the patterns where each output unit represents a class. As it uses supervised learning, the network will be given a set of training pattern with known classification along with an initial distribution of output classes. See, this is how it is very much different from what we call as supervised learning. Now, after completing the training process, LVQ or learning vector quantization will classify an input vector by assigning it to the same class as that of the output unit. Now moving forward, the architecture. The following figure shows the architecture of learning vector quantization, which is quite similar to architecture of KSOM or like Kohonen's model. As we see, there are n number of input unit and m number of output units. The layer are fully interconnected with having weights on them, like we are having different weights on it. Further, the parameter used in this are the following are the parameter used in LVQ training process as well as in the flowchart. X indicates the training vectors, T indicates the class for training vector X, WJ indicates the weight of vector for jth output unit, CJ includes or CJ indicates class associated with jth output unit. So these are the different parameters used. Now this is a pictorial representation or a flow chart representing how the things will work with reference to it. First, like initializing the weights and for the learning rates, and we'll check for the input of x vector. If at all it is yes, then it will move forward for obtaining winning units of index for d of j, which is equal to minimum. Then it checks for the condition. If the condition is true, it updates the weight. If the condition is false, it updates the weight using the formula so and so. Now if at all and the condition is true, then it move forward for reducing the learning rate or to reduce the learning rate. And if the everything is been like if the learning rate reduces to the negligible value, then it stops for the thing, or else it will again continue the process until and unless we are getting the negligible value for the things. Now this is a flow chart or flow diagram for the things. The next one is the counter propagation network. Now what it is, a counter propagation network were proposed by Nelson in 1987. They are multi-layer network based on combination of the inputs, outputs and clustering layers. Now what further it says, the application of counter propagation net are data compensation function or approximation and pattern association. The counter propagation network is basically constructed from an instar-outstar model. Instar or outstar model. Now what this further says, this model is a three-layered neural network that performs input-output data mapping, producing an output vector y in response to input vector x on the basis of competitive learning. The three-layer in-star, out-star models are the input layer, the hidden or competitive layer, and the output layer. Basically it has three layers. The first one is the input layer, the second one is the hidden layer, which is also called as competitive layer, and the third layer is the output layer. Now further it says there are two stages involved in training process of a counter propagation network. The input vectors are clustered in the first stage, wherein these in the second stage of training, the weights from the cluster layer unit to be output unit are turned to obtain the desired response. Now what it says, there are two types of counter propagation network. The first one is the full counter propagation network, and the second one is forward only counter propagation network. Now we'll see what are these types. Now what is full counter propagation network? In full counter propagation network efficiently represents a large number of vector pair in x and y by adaptively constructing a lookup table. The full CPN network best if the inverse function exists and is continuous. The vector x and y propagates through the network in a counterflow manner to yield output of vector x star and y star. It indicates the propagation value with reference to full propagation network. It like this is the counter propagation for full counter propagation network. Now what is the architecture of full CPN? Now what it says, the four major components of the in-star outstar models are the inputs layer, the in-star, the competitive layer and outstar. For each node in the input layer there is an input value of xi. All the in-stars are grouped into a layer called the competitive layer. Each of the in-star responds maximally to a group of input vectors in a different region of space. An outstar model is found to have all the nodes in the output layer and a single node in competitive layer. The outstar looks like the fan out of a node. This is a diagrammatical representation of architecture of full CPN. Now what is forward only counter propagation? Now what it says, a simplified version of full CPN is the forward only CPN. Forward only CPN uses the x vector to form the cluster on the Kohonen units. Now, during the phase 1 training, in case of forward only CPN, first input vectors are presented to the input unit. First, the weights between the input layer and cluster layer are trained. Then, the weights between the cluster layer and output layers are trained. Now, what this happens? This is specific competitive network with target known. Now, further moving, the architecture of forward only CPN is, it consists of 3 layers. The first one is the input layer, the second one is the cluster layer, and the third one is the output layer. Its architecture resembles the back propagation network, but in CPN there exists interconnection between the units in a cluster layer. Now, moving forward, what is adaptive resonance theory? What is adaptive resonance theory? This network was developed by Stephen Grossberg and Gale in 1987. It is based on competitive and use unsupervised learning model. Now, adaptive resonance theory networks, as the name suggests, is always open to new learning adaptive without losing the old pattern resonance. In the sense, it will learn a new thing in comparison to the old methods and old things that is been associated to it. Now, third point is, basically ART network is a vector classifier which accepts an input vector and classifies it onto or into one of the category depending upon which of the stored pattern it resembles the most. Now, moving forward, what is the operating principle with reference to this? The thing is, the main operation of ART classification can be divided into the following phases. The first one is the recognition phase, the second phase is the comparison phase, and the third phase is the search phase. Now, what is the recognition phase? In the in recognition phase, the input vector is compared with the classification presented at every node in the output layer. The output of the neuron becomes 1 if it best matches with the classification applied, otherwise it becomes 0. Now, the next what you call as phase is the comparison phase, into which in this phase a comparison of input vector to the comparison layer vector is done. Now, this condition or the condition for the reset is that the degree of similarity would be less than vigilance parameter. It will be less than the vigilance parameter. The third phase is the search phase. In this phase, the network will search for reset as well as the match done in the above phase. Hence, if there would be no reset and the match is quite good, then the classification is over. Otherwise, the process would repeat and the other stored pattern must be sent to find the correct match. So, this is with reference to the operating principle. This is with reference to the operating principle of the things. Now, this completes our 4th unit. If you have any doubt with the reference to the 4th unit, you can email me on my email address rahmat_ali2u@yahoo.com, or you can come down to the college for a personal doubt clarification session. Until then, take care, bye bye, have a great day. And also, we'll be soon having a doubt clarification session soon on a Zoom meeting, if at all time permits and if at all the things are being feasible, then we will be conducting a Zoom meeting. And if at all, if you have anything to ask, and with reference to the notes, I'll be giving the presentation to all of you. You can take this material for your as a notes and for studying the things, and every of the material is available online in forms of videos, in forms of PDFs, and in forms of the different documents. I hope you understood something from today's session. See you in the next session. Until then, take care, bye bye, and thank you for joining.